Well, hello, everyone. I'd like to welcome you all back to the second week in the research class, and this is the second lecture of the series. Before we start, I'd just like to touch base about last week regarding the discussion board, the coffee shop discussion board. I just wanted to give a little feedback about that. I think everyone did a really good job in coming up with some ideas and some topics that I thought were very thought-provoking for the class. So keep up the good work on the coffee shop discussion board. Yeah, so let's get started with this week's agenda. And it's kind of a two-part agenda. And the first part is going to just give you a sense of, it's going to have a little bit of like a writing component in terms of, the manuscripts. So I'm going to lightly go over some of that because we're going to go back to that at the second part of the semester. But it's the second, in terms of looking at research problems, questions, and hypotheses. But it's the second part of the lecture that I really want to focus in terms about validity and reliability in research, because really that's the root of an empirical study. Whereas I would say that the first part of the lecture in terms of research problems, questions, hypotheses are kind of the root of the manuscript for an empirical study. So let's go ahead and begin. Basic ingredients in a research article. Of course, we're looking at quantitative research articles at this point. Qualitative research articles are pretty much the same. The ingredients might look a little different, but the structure is pretty much there. When looking at an article, of course, you're going to, have an abstract at the beginning, and that can range anywhere from 25 words to 50 words, but even as far as I think APA allows for over 200 words, which most manuscripts don't really allow, because the more words you put on a manuscript for publication, the more money it costs them to print it. So there's that. Of course, we have the literature review, and the literature review is really where the research problems, the purpose of the study, and the questions and the hypotheses are presented. So that's what we're going to focus in on today, and as just as a general review, and then we'll come back to it later on. So then we have the methods section, which lists the design, the sampling methods, instrumentations, procedures, and then the analyses, which is or the results, which is how they answered the question, through a statistical analyses. Tables, figures are all used, and then the discussion, which is the review of the results in relation to the question, and then implications for like what future research studies could come out of that, limits of the study, and then general conclusion. But once again, I'm going over this quickly. We're gonna hit this harder after the midterm, so I'm just kind of giving you a basic sense of the structure. This is really what I want to focus in on today, because I want you to start thinking in a sense of linearity, I think, with some of the stuff. And when you read a manuscript, especially, of course, an empirical study, you have to think about these things in terms of, that they're going to happen in some kind of linear nature. So it's always going to, the article should always start off with the research problem, and then move to the purpose of the study, and then the question and or hypothesis. Now, a manuscript doesn't have to have a question and a hypothesis. It kind of depends on how much literature they're reporting and how much literature there is on the subject for them to possibly formulate a hypothesis. We'll get to that in a little bit. So the first one is a research problem. And there's usually two types of research problems in a manuscript that hopefully that they'll cover both. Sometimes they don't, and that's okay. But the general one is that it's presenting, the problem itself is that it's presenting an unknown. We don't know about a certain issue. We don't know enough about a certain topic. So there's a gap in the research that hasn't been explored. There's a set of variables that haven't been related together. There's a certain group of individuals that haven't been studied in a certain way, and part of it is just to fill in the unknown gap. But the other research problem is that there's a dilemma within society. There's a problem that is occurring in society, that by studying it and understanding it more, that we're going to be able to possibly help with the dilemma. So, so really these types of research problems go hand in hand, that there's something wrong in society that we need to learn more about because we don't know enough about it. And the research isn't answering these questions as of yet. And so when you read a lit review of an empirical study, get a sense of what the research problems are. Where's the gap in the research, and why exactly are they conducting the study? How's it going to make life better for society? Okay. Examples of research problems, these are just ones that I might have made up or found in the literature. So the first one is, to date, no research has been done to explore the relationships between frustration and aggression levels in Hispanic American adolescent females who live below the poverty line. So, this is that gap in the research, that we haven't looked at the relationship between the variables of frustration and aggression in a specific group of people living under the poverty line. And then, so that's the gap in the knowledge base. But then the societal issue is an increasing rate of violence in older adults who live in assisted living communities continues to escalate at an alarming rate. So this one is, the unknown, like we don't know what the relationships are between these variables. And then this other one is example of research problem, is basically saying that there's a lot of violence going on in assisted living communities between older adults. And not that, these, of course, these two examples aren't related to each other, but it just shows an example. So the research purpose, also called the rationale for the study or the purpose of the study, this is basically the argument for why the study should be done, and this should be in direct relation, almost to almost like a ridiculous relatedness to the problem. Is it has to be based on the research problem in terms of in terms of why it should be done. So the rationale has to line up directly with the problem. So if we go back to, I believe, if we go back to an extension of the problems that I just mentioned to you, these are just extensions to the problem. So in regards to the first one, therefore, we intend to study the relationship between frustration and aggression within the population. By doing so, new clinical implications can be constructed to help reduce aggression. So it's directly related to the problem that was stated. Also for the one with older adults, the purpose of the study focuses on understanding older adults' lived experiences within assisted living facilities. So it's giving you, the purpose specifically of what they're intending on studying. It's more of a qualitative purpose, but that's fine. It's still a good purpose of the study. Now, the question itself, the research question is the one thing in the study that actually drives the study. And this is the one that you really, if you don't read anything else in a literature review, you want to find the research question, because it's going to tell you what groups might be compared within the study, or what variables might be related to each other in terms of how they're going to, what variables they're going to study. So always find what the research question is, and it should always stem, once again, directly from the problem and the purpose of the study. And usually research questions are ones that haven't been ever been answered in the literature. Sometimes you could have a replication study and it uses the same research question, and that's fine. But typically, it's not. Typically, it's a brand new question. Now, the thing is that research questions are typically used over hypotheses when there's just not enough to there's not enough theory in the literature, or there's not enough existing research in the literature to make an informed guess, which is what a hypothesis is. So if you don't know enough, it's always easier or safer to just ask, or to develop a research question. So that way you're not making assumptions or guesses that's based on nothing. Questions are safer; they're easier. Questions can be simple or complex in nature. So a simple, and I guess we'll get to that in a second. Research questions, when you read them, they should really be clear, they should be simple, and they shouldn't be too wordy. They should really just say just enough to get, to ask the question. You don't want to throw too much into a research question. So there's types of research questions, and once again, we're going to get into this when we get into the writing. But there's descriptive questions, and descriptive questions are only asking, the question of what is, in terms of what a phenomenon is like in its untouched state. It can be qualitative or quantitative in nature, by design. And there's no active manipulation of variables. So there's no looking for relationships between variables or differences between groups. There's no experimental design being used, and there's no inferences made about variables. It's very much what is the percentage of people that like chocolate ice cream over vanilla ice cream, things like that. So here's an example of a descriptive question. What needs do employees possess in retirement to their upcoming retirement? So this might be more of a qualitative question, where you would interview people who are retiring, and ask them, what do you need? And they might have psychological needs, sociocultural, sociological needs, financial needs, personal needs, whatever. It's a very open-ended descriptive question. Whereas, what are counseling students' levels of interest regarding counseling older adults? That might be more of a quantitative question that is, once again, very simplistic, based on percentages and not so much looking at relationships or differences and using any involved statistics. It's basically just kind of counting how many people, how many counseling students are interested in working with older adults versus not. Other questions, actually, I'm just going to skip over those. You can read them if you want. You can pause and read, but they're just more questions. There's also relationship questions, looking at the relationship or correlation or even association between two or more variables. Examines the degree by which the variables are related. So how related are the two variables, that you're studying? Are they very much related? Are they not related at all? Are they positively related? Whereas one variable increases, the other one will increase as well? Or are they negatively related in terms of, as one variable goes up, the other one goes down? So let's say, let's say you're measuring depression and sadness, and they're very related, but as depression increases, so will sadness. Whereas if you're looking at sadness and happiness, as happiness increases, sadness will go down. So they're negatively related. They can be simplistic or complex by nature. Now, a simple one, this is an example of a simple relationship question. What is the relationship between frustration and aggression in Hispanic American adolescent females who live below the poverty line? That is very simplistic because they're only looking at two variables, frustration and aggression, which you would use a bivariate statistic. Most likely you would use Pearson product correlation. So that's a very simple question. A more complex question would have more variables included, such as what relationships exist between wellness, motivation, anxiety, and self-esteem in master's level counseling students. It's very complex in nature. and it's going to involve more complex types of statistics, such as maybe a regression analysis, multiple regression analysis, things like that. So there's simplistic and there's complex. There's also, here's some just other ones as examples, and you can pause it and read through those if you wish. There's also difference questions, and that looks at differences between groups of people or individuals concerning over a variable. So whereas relationship questions looks at relationships between variables, difference questions looks for differences between groups. Now, this is a concept that most students have a hard time grasping. So what I would do is, you might want to write this down or go back and rewind this and watch that several times in terms of what I just said, because it is important. That's a very fundamental aspect of research that students have a hard time understanding at times or grasping. Difference questions can be linked to comparative designs, both experimental and non-experimental. And we'll get into all of that as the semester progresses. You don't need to really think too much about that right now. Examples of difference questions. If you were looking at counseling students, are there differences in wellness levels? Now the wellness levels, that's the variable, with counseling students who are engaged in a wellness curriculum as opposed to counseling students who are not engaged in a wellness curriculum. So you would have two groups of counseling students, one in a wellness curriculum, one in not in a wellness curriculum, and you would look at the difference levels in wellness to see if there's if differences. Another one, do Hispanic adolescent females who live below the poverty line possess higher levels of frustration and aggression when compared to Hispanic adolescent females who live above the poverty line. So there's two groups, above and below the poverty line, and you're looking at frustration and aggression levels as variables. And then there's just more here. If you want to pause it and look through those yourself, that would be great. Okay. When critiquing a question, of course, you want to ask, does the question make sense to you? Also, is the question actually asking a question? You wouldn't believe how many times that the questions isn't really in a question form, or it's not really asking a question that can be answered. So you have to be very careful for that. Also, what type of research question is it? Is it descriptive in nature? Is it more of a relationship question, or is it a comparative question? And also, is the question measurable? Sometimes, it can't be answered. So you have to make sure that it's something that can actually be answered. Variables within the question must be clearly defined, given the operational definition. So the thing is about, if you look at all of these, variables, if I would ask each one of you to operationally define what your definition of self-esteem, depression, gender identity, wellness, and acculturation is, they might be slightly different. So the thing is that each researcher has to, draw, stake claim to what they, to define what the variables that they're studying, actually mean. And typically they find these definitions in the literature. So, okay, moving on to a hypothesis. Now, a question is simply a question, a wonderment, what are the relationships between these two variables? Would differences exist between these two groups on a variable, or two? But a hypothesis is actually a guess or a prediction. It's not a question. It's a statement that is, or a declaration that of what will happen when you run a study. And it's a prediction. It tells you or predicts about relationships between variables or differences between groups. So, you're sticking your neck out a little bit more in terms of, making a guess rather than just asking a question. Now, hypotheses, like I said, are used more when you're more certain about which way the results should go. And this is based on theory, psychological theory, or previous research results. So, if the research has been saying or suggesting over and over again that aggression is highly related to frustration in a number of different types of groups, then for you to predict that aggression and frustration are highly related in a group that hasn't been studied, perhaps, that's going to be a little safer than if no research had ever looked at those two variables before. Okay, so let's move on. Two types of hypotheses, and this, the first one is going to be the research hypothesis, and this is the statement about what you expect the outcomes to be for the variable or variables under study. So if you're thinking that that frustration and aggression are very much related, and you state that they will be, that will be your research hypothesis, that those two things are very related, or two groups that you're going to study that you think will be significantly different will, that will be your research hypothesis. So an example of a research hypothesis would be participants in the Gestalt group, Gestalt therapy group, will have significantly lower levels of depression than participants in the control group. Or there will be a positive relationship between frustration and aggression levels in Hispanic American adolescent females who live below the poverty line. So both of these are predictions that Gestalt is going to be better than control, that there's going to be a relationship between frustration and aggression within the specific group. Now, the null hypothesis, as you probably remember from your undergraduate days, is a hypothesis of no difference or no relationship, that there's going to be nothing to see here in terms of the results. And we either reject the null in a study, or we fail to reject the null. Now, I don't like double negatives, and you might not either. So, I'm going to be very lenient in class and say that you can either say that you reject or accept the null. Now, a statistician would not like that because it's either reject or fail to reject the null. By accepting the null, they would say that you are accepting the idea that the null is true. And I'm not going to mince words, but basically what I want, what I want you to know from this class is that when you reject the null, that means that the research hypothesis has found significant differences in relationships. And when you accept the null, that means that there are no differences in relationships found in the study. So there's that. So examples of null hypothesis would be just the very opposite of the research hypothesis. So if you look at the Gestalt hypothesis, it would read, there are no significant differences in depression levels between participants who are in the Gestalt group and the control group. Or there will be no relationship between frustration and aggression levels in Hispanic American adolescents who live below the poverty line. So there's that. Writing a hypothesis has to be pretty much in the same characteristics as a question. That if there is a question and a hypothesis, that has to be a clear reflection of the research question. Typically, studies don't have a question and hypothesis unless you're writing a dissertation, and then you're doing that just for the sake of practice for the academic exercise. But when you get out into and you start reading manuscripts, they're not going to want both. But hypotheses have to be clear, simplistic, and not too wordy, and one prediction for each hypothesis. And I'll show you what that means. So a bad hypothesis would be, we hypothesize that the intervention group will have significantly lower levels of depression, anxiety, and suicidal thoughts in comparison with the control group. Well, why is that a bad hypothesis? If you need to, pause the lecture for a moment and think about it. If you don't need to pause, let me tell you that this is a bad hypothesis because there's more than one variable that's being hypothesized in this hypothesis that we have depression, anxiety, and suicidal thoughts. So, for example, if you hypothesize that that the intervention group is going to have significantly lower levels of all three of these, what if you find out in your study, in your results, that suicidal thoughts are significantly lower, depression is significantly lower, but anxiety remains the same? Is the hypothesis, do you reject it or do you fail to reject it? So that's the thing. So what you need is one variable per hypothesis. So you would say that we hypothesize that the intervention group will have significantly lower levels of depression in comparison with the control group. And then you would have another hypothesis that only states suicidal thoughts, and then another hypothesis that states only anxiety. So that way you can accurately reject or fail to reject each hypothesis. Okay, now let's move on to what's probably more important at this point in the lecture in terms of what you need to know related to the class. And now that I have just made myself a fresh cappuccino, I'm ready to discuss validity and reliability. And the thing is that the reason why this is so important is because this is the crux or the root or of the quality of any study. So anything that we talk about from here on out is going to be linked back to validity and or reliability issues that ultimately will be, the final judge of whether a study is poor or whether it's of good quality. So, okay, so the first one, I gave you this this slide last week in terms of the basic definitions of validity and reliability. And really what it is, once again, it goes back to that you have to know what you're measuring or what you're studying or what you're manipulating is really what you're measuring, studying, or manipulating. How do you know that? How do you know that you're not looking at or studying or measuring something else? Or how do you know your intervention is really honed in on what you think it's honed in on? And that's validity. Whereas reliability is replicability and consistency of your studies or of your methods, conditions, and results. So, and there's two types of each. And this is when we get into the real details. And we're going to start off with internal validity. And I'm going to be honest with you, this is the one that students struggle with the most. So I'm going to try to be clear. I'm going to try to give you multiple examples and do my best with this. So internal validity, and I'm going to read this off the slide and then I'm going to talk more about it. It's the degree to which we can be confident that the change in the individuals under observation, which is your results, that are the people that are in your study, occurred because of what you as the manipulator researched, or what you as the researcher manipulated. So think about this example. Let's say you are working in the VA and we have military groups coming back from their deployments, and they've been correctly diagnosed with PTSD and they need some help. And you've just come up with this this really good, like let's say group therapy for PTSD that in your anecdotal experience that it's found to be helpful. So you want to run some groups and to systematically understand whether this intervention works or not. Your question should always be, how do I know it's the intervention that I'm giving them, or if it's some other variable that I have no idea that might be affecting their PTSD? For example, if they're on like medication, how do we know that it's your let's say Gestalt group intervention that's affecting PTSD levels and not the SSRIs that they're taking, or the fact that let's say half of them are very spiritual and go to church and they implement spirituality into their life that could affect their PTSD. Internal validity will always ask that question. How do you know it's the intervention that you are providing that is really causing the changes that you're seeing? Okay, so that's more of an experimental example of internal validity. Um, a more non-experimental example of internal validity would be the degree to which we as researchers can be confident that the relationship exists between two or more variables. How do we know that, let's say in survey studies, that we're looking for relationships between, I don't know, wellness and physical exercise? How do we know that that what we're seeing is really what is happening? So one question you might want to ask yourself that might affect internal validity: did the participants answer truthfully? Maybe there's always the social desirability issue. That participants want to uh, look better than what they actually are. Maybe they're reporting that they go to the gym 4 or 5 times a week, when in fact that they're not. They never go to the gym. Or they might report that they're more well than they actually are, when in fact they're not well at all. And did the instrument measure what was intended? So, there's instruments out there that say they're measuring wellness. Well, are they really measuring wellness? I don't know. Also, did the participants ever, are the participants that say that they completed the study, was it really them that completed the study or not? Or was it their significant others that got online and complete? Because there could have been an online survey, and they sent it to, let's say, counseling students, but let's say one of your friends answered it. Also, your state of mind at the time that you completed a study. Let's say you just found out some horrible news and you're very upset, and you answer or you fill out a survey in a state of crisis. Is that state of mind a true depiction of what life is really like for you, or is it kind of is it not? So in a sense, when evaluating internal validity or trying to control for internal validity as a study, there's 3 things that we can account for or try to pay attention to. The first one is the equivalence of participant characteristics between groups. Now, if you're running a comparison study where you have group A, group B, or group A, B, and C, or whatever, you want to make sure that the participants' characteristics between the 3 groups are as similar as possible. So you don't want, if you're studying, let's say, depression, and let's say you're running a clinical trial where you want to see if there's differences between the groups in depression after the interventions were given. You want to make sure that all 3 groups have the same level of depression. You don't want group 1 to have profound depression, whereas group 2 have minor depression, and then group 3 have like moderate depression, because that's going to affect your results. Equivalence of participant characteristics within groups, that you want to make sure that the participants within each group is pretty much the same as well. That if there's too much variance between the groups or too much differences, then that's going to flaw your results. Also, controlling for extraneous variables. Extraneous variables are huge, and trying to that you can't control for them all, but try to control for as many as possible. Now, when we get into selection processes, for participants, we're going to note. I'm going to note that random selection and random assignment of group. Random selecting, if you can randomly select participants for your study, and then randomly assign those participants to let's say one of the 3 groups that you're running, that is going to account for all 3 of these things to the greatest extent that you possibly can. So there's that. And that's the contributions to validity. Random selection, of course, also called random sampling. That's giving participants from a given population an equal chance to be in a study. So selecting all LPC licensed counselors for a study. Let's say you want to do a study of LPCs in terms of their mental health. you might want to randomly select out of all, and really LPCs are independently licensed counselors. So you might randomly select, let's say, out of all 50 states, you might select 5 states to and out of the union, and then randomly select out of those 5 states that if you can randomly select let's say 400 people per state, let's say, out of the list of all LPCs on the registers of those states, something like that. I mean, that's kind of an extreme and almost impossible example, but it's an example to give that that you could. Random assignment is once you have your sample of individuals, of participants, you would assign them randomly to however many groups that you have. So if you have, let's say, 20 people that you've randomly selected for the study, you have 2 groups, you would randomly assign 10 to one group and 10 to another group. So now there's certain threats to internal validity that are going to magnify the differences between groups and also the similarities between groups. Now, for the sake of time, I'm not going to go into each one of these. What I'm going to do instead is I'm going to upload a list of all of these things that have definitions of each one and that are going to have examples of each one that I've created over the years. And what I want you to do is read through those, and I want you to know them, in terms of at least being able to be familiar with them. So, there's a lot of them. So this is going to be threats to internal validity that magnify the differences between groups. For example, like mortality if people drop out of a study, instrumentation if the instrument that you're using to measure the variable might be flawed, resentful demoralization of the control group. So let's say you have 2 groups, one's the intervention group, one's the control group, and the intervention group is getting all of this really good up-to-date type of treatment, and the control group is just getting the same old. If the control group finds out that they're in the control group and that this other group is getting like advanced therapy, they might just become demoralized and stop trying altogether, and thus magnify the difference between the results between that group and the intervention group altogether. Threats to internal validity that magnify the similarities between the groups, diffusion of treatments, the rivalry of the control group, and equalization of treatment. So a couple of things here, and I'm not going to give you examples of all these, but like diffusion of treatments would be, let's say you have 2 groups, you have the control group and the intervention group, and it's like, let's say it's an in-house facility. It's let's say it's I can't think of the word, inpatient facility. And, let's say 20 people are getting the treatment, the intervention that you're studying, and 20 people are getting the control. Well, and you're doing a pretty good job of separating, these 2 groups running at different times. But let's say they all get together and eat lunch at the same time, at lunchtime, and they're talking about their treatments. Well, they might just talk about what they're doing in therapy, and, some of the intervention folks might say, well, yeah, we're doing this, and we're taught to think about it this way, and we're taught to journal, and we're taught to, do all these other things to the control group people, and the control group people might just start doing that. And the results might magnify the similarities between the groups. So, the secret got out in a sense. Rivalry of the control group, instead of becoming demoralized, they might say, you know what, we're gonna get better to spite you because we're getting this crappy control group intervention, and I know that there's all these bells and whistles down the hall, so we're just going to get better to spite you. So there's always that. Okay, that does it for internalized internal validity. Once again, I'm gonna I'll send you that form, and I'll put it in Moodle under week 2, and then you can have that for your as part of your study guide for the test. External validity And this is just the extent to which the results of your study can be generalized to the overall population. Now, the thing is that you're never going to be able to generalize to the overall population, like the overall population, because there's always going to be limits to that. So, you know, the overall population could be, let's say you're studying LPC's mental health, and you're comparing, you know, or whatever, and you're looking for relationships between, you know, all these variables relating to their mental health. You know, that study will only generalize to the overall population of LPCs, and maybe even just an overall population of LPCs, of like maybe a subpopulation, maybe not all LPCs, but just based on, you know, the demographics within your study. So based on the sample I took from, what is this? Oh, okay, so that's the question that you have to ask yourself. You know, how generalizable is the study, you know, in terms of like, if you're running the study, how, you know, how do my results generalize? Who do my results generalize to? So let me ask you this. The example is soldiers diagnosed with PTSD. Let's go back to that. That let's say you're the military personnel that you're working with, you know, let's say it was just from, let's say the Air Force, and, you know, that runs, you know, special operations, you know, through the Air Force. Would this study be generalizable to maybe military personnel in the Army? And I would say probably not, because unless they did the, you know, a lot of the, or saw the a lot of the same things, or did a lot of the same things, I would say no. This is probably generalizable to only Air Force military personnel, and because let's say, you know, that you know, I don't, because there's so many variables that could be different about how the PTSD developed and how the intervention is approaching those stories and those those etiologies, that that you might only be able to generalize to a specific military group, and not all military groups. So threats to external validity, there's a whole list of them as well. I have a form, you know, I have a whole list of these that are in, and they're also defined, and they're also given examples. So I will, it's on the same form as the internal validity, so I'll send those to you. Okay, so internal reliability. So where we have validity, asking the questions, am I studying what I really think I'm studying? Are my manipulations, are my interventions really causing the differences or the relationships that I'm seeing in the variables or the groups? And then external validity is, you know, and how generalizable are these results? You know, who are they generalizing to? Internal reliability is going to another extent, in terms of the extent to which the data collected, the analysis, the interpretations, and the coding data are all consistent. So really what this is when you did a study, did everyone in the study get the same thing? You know, it's the consistency of your procedures here. It's, did everyone get the same intervention? Did everyone get the same, you know, did everyone take the same instruments, in terms of, like, you don't want to give, you know, your intervention group the Beck Depression Inventory, and then give the control group some other depression inventory, because those two inventories are going to measure depression in different ways. It might define depression in slightly different ways, thus making your reliability, that's lowering your internal reliability, and also lowering your validity for the study, your internal validity, because internal reliability is directly related to internal validity. So that's the thing, is that everyone really has to get the same, has to go through the same procedures, and take the same instruments and everything for internal reliability to be high. And typically this isn't a problem, but it's something that you have to ask yourself when you're reading a study, and you're going, you know, and you're reading through the procedures, you know, asking yourself, okay, did everyone get the same thing? And if not, then why? External reliability is really the extent to which researchers can read a study and replicate the study based upon based on what they read in the article. So is the journal article giving you enough description to the point where you could go and you could replicate that study based solely on the description that they're giving you in the methods and results section? Is there enough detail to do that? So, for example, and these are just some things to think about. How was the data collected? Exactly how long was the intervention given for, in terms of an empirical study? What stats were used to analyze the data? Most of the time, that's all given. Sometimes, though, it's not. How did researchers sample the participant? All of these things, that there's sampling methods that need to be described. There's analyses that need to be listed and described. There's if it's some kind of an intervention, there has to be procedures in terms of what did they do, and then what did they do first, and then what was the second thing they did, and how long were all these interventions for, and if it's a specific prescribed intervention, how do I get in touch? How do I find that intervention so I can use that exact same intervention? So, okay, so that's pretty much it. Those are 4 concepts that I really want you to know. I want you to know them well. You're going to be tested on them, of course, but in order to build on, for the class, all the content that we're going to be adding on to it, you really need to know these 4 concepts, and you need to know them well. So just, maybe go through the lecture again. If you have any questions about anything, bring them up in the coffee shop discussion board. Email me directly if you have any specific, questions. But yeah, hopefully these things are pretty clear to you. Okay, well, have a good week, and I'll be watching out for you on the discussion board, and I will see you next week.